Welcome to Positive Physics, and today we're looking at the self-isolation electricity story. This is just a little bit of fun, hopefully an analogy to help you understand how potential difference is shared in a series circuit. It's an analogy. The ideas are going to break down at some point, but I've had some fun thinking this up. So, imagine, if you will, a Year 11 student stuck at home and newly finding himself with absolutely nothing to do, given that all his exams have been cancelled. So his mum is sending him out of the house to go and collect from the supermarket some loo rolls. After all, everybody's looking for them. So our little Year 11, who looks very much like an electron with arms and legs, is walking to the supermarket. But there's a queue to get in and he's having to wait for the doors to be opened. But soon those doors get opened and he's in. And our little Year 11, or not quite so little, depending, has managed to get into the supermarket and he has got 4 loo rolls. Now he's continuing on his journey and Mum's told him he's got to stop off at Gran's house in order to give her and his granddad 2 loo rolls. Our Year 11 knows he's not going to get to go back there for a while because they're protecting themselves. So he drops off too. Then he carries on round on his journey back home and he goes to the neighbours. And unfortunately his neighbour is self-isolating. He's been a bit poorly, he's on the mend, but he also needs 1 loo roll. And finally, this little Year 11 makes his way all the way home and gives 1 loo roll to his mum, sits down and tries to get on house party to have a chat with his mates. Anyway, bit of fun, but let's have a look at what's going on and try and relate it to an electric circuit. Obviously we have our switch. Our supermarket is behaving like the cell in our circuit. Gran's house and his home are a bit like lamps that once the switch has closed, they're on. And our neighbour's house is a bit like a resistor. So we've got 3 components in our circuit and 3 places that the Year 11 visited, having been to the supermarket. Let's think about numbers of loo rolls. If we were to look at the little Year 11 before he went through the supermarket and after the supermarket, here he had no loo rolls, there he had 4 loo rolls. You could say that the supermarket had given 4 loo rolls per Year 11. And that's a bit like the EMF of a circuit, where the cell gives the electrons, or gives the charge, energy. So I'm going to write over here an equation, V E over Q. And all this is saying that the voltage of the cell, or the EMF of the cell, is equal to the energy per unit charge. So whereas we had 4 loo rolls per Year 11, if this cell was measuring in, if we were looking in volts, it could have, say, 4 volts. Then that would be the same as 4 joules of energy per coulomb. And all a coulomb is, 1 coulomb is a lot of electrons it's actually 1.6 times 10 to the 19 electrons. That is 1, 6 and 18 zeros. Too many for me to write out. Okay, it's just a huge number of electrons, this coulomb of charge. And 4 joules have been given to all those electrons. But it's just the same as thinking of 4 loo rolls being given to each year 11, 4 joules being given to 1 coulomb of charge, all these electrons. So that's what our cell's doing. When the current, because there's current flowing in our series circuit because we've got a complete circuit and the switch is shut, when the current is passing through the circuit, those here, our year 11 transferred 2 loo rolls to Gran. So if we were to look at this point here in the circuit, the year 11 had 4 loo rolls. And if we were to look at this point here in the circuit, the year 11 had 2 loo rolls. There's a difference of 2 loo rolls. Now we can think of that as a difference in the potential to give loo rolls. Here, he had the potential to give 4 loo rolls. Here, he's got the potential to give 2 loo rolls left because 2 loo rolls have been transferred to Gran. Going to our electric circuit, we put our voltmeter across our component, and what it does is has a little look at what's going on in the circuit before and after the component. So here it's saying, well, how many joules have each coulomb got at this point? So if the circuit, it's got 4 joules per coulomb at this point, or 4 volts. Here it's transferred 2 joules per coulomb to our lamp, and we now only have 2 volts. So our difference in potential to transfer energy when we're looking at our charge is 2 volts. So where Gran, we had 4 loo rolls here and 2 loo rolls there with our year 11 going round his circuit. If we're in our electric circuit and we had a little look in the circuit at that point and this point, we would have 4 volts here and 2 volts there, and our potential difference is 2 volts. Thinking of the same thing now, we've not transferred any more loo rolls until this point here. So if we were to look at this point, we would have 2 loo rolls, we've transferred 1, and 1 loo roll. So our difference in loo roll potential is 1 loo roll. But again, if we imagine putting our voltmeter into our electric circuit, so there's our voltmeter across this particular resistor component, then if we look here, we've got 2 volts. And if we look here, we would have 1 volt. So our potential difference is 1 volt. So finally then, when we get back home, we can do exactly the same thing. 1 loo roll in the year 11's bag before he goes indoors to home. No loo rolls as he goes out again. Not that he'll be going out for a while, but if he were, this is where it breaks down. Okay. 1 loo roll here, 0 loo rolls there. Or if we're thinking about our electric circuit, we've got 1 volt at this point here and 0 volts at that point there, and so our potential difference is 1 volt. And what we end up seeing is that in our series circuit, when we're thinking about year 11s and loo rolls, our cell provided 4 loo rolls and they are shared within the circuit. So our 4 loo rolls, we've got 2 plus 1 plus 1, which is 4. And in this case, it was in relation to the number of people or the need. In an electric circuit, we've got 4 volts, which is shared 2 volts, 1 volt, 1 volt in our series circuit, and it's shared with relation to the resistance. So this would be a much higher resistance lamp than this one, and this lamp and this resistor would have the same resistance as each other because they each have the same potential difference across them. But we'll talk more about resistors in another day. But the main rule to remember is that the total potential difference, I'm going to write PD, in a series circuit is equal to the sum of the PDs across each component in series. I hope that's helped, and I hope thinking about loo rolls being delivered by Year 11s who are desperately trying to find something interesting to do has helped you understand potential difference being shared in a series circuit.